Welcome to the video lecture series of data structures. Our today's topic is queue and simple queue insertion and deletion. Hi, this is our instructor Janice Shah. So let's begin with today's outlines. Students, first today we are going to learn about first we'll see the queue, then simple queue, then we'll talk about the insertion in simple queue and deletion in simple queue. So here it is. The first question should come in your mind, sir, what do we mean by queue? Okay. So the thing is, when you are standing in a queue to take a ticket of a movie, then what happens over there? If you are the first one, then you will get the ticket and go out from the queue first. Again, I'm repeating this. If you are standing to take a ticket of a movie, then what happens? You are the first one, you just take the ticket and go out from the queue first. Your next person will take the ticket after you, get the ticket and go out from the queue again. So this is nothing but this is known as a first in first out manner. Students, always remember that the queue follows first in first out manner. Fine. So here the example of a cars which are standing in a queue. The first car will get the first chance to go out from the traffic. Fine. Here the another example is there, students. If you can see the line over there, okay, the queue of a person. Next, students. So what do we mean by queue? So now let me tell you, the queue is a linear or non-linear. Queue is a linear data structure. Fine. In which the insertion and deletion occurs at two different ends. Okay. So do not forget to remember that the queue is a linear data structure in which the insertion and deletion both happens at two different ends. Students, the end from which we are going to insert an element, that end is known as rear, and the end from which we are going to delete an element from queue, that is known as front. So remember, the rear is used to insertion an element and the front is used to delete an element from queue. Okay. So here it is. The insertion and deletion occurs in first out manner. So nothing. The queue is a linear data structure in which insertion of a new element occurs at one end, which is known as rear, and the deletion of the element occurs at the another end, which is known as front. Here are some types of queue, students. Number 1 is a simple queue, number 2 is a circular queue, and number 3 is a priority queue. Number 4, the last one is a double-ended queue, which is also known as dequeue. Here in this figure, students, if you can see that the front and rear both pointers are there. Fine. Now let's begin towards the next point. Students, the next point is algorithm for simple queue insertion. Okay, so it is very much easy to understand this topic. Okay, just listen it very carefully. See here in this subject we are going to take the array indices starts from 1. So my each and every step of the algorithm is written according to it only. Okay, so do not forget that the array indices starts from 1. Okay, so here this is an insertion process. This is a insertion of a new element in queue. That's why I'm not going to take or return any element from the queue at the end of the function. Okay, so what this algorithm calls? See, here I'm not going to return anything. Here I'm not going to return anything. Then what does it call? It is known as procedure. Fine. So students, this is my procedure. Here I'm going to show you the procedure. Okay. Then okay. Why we are using this algorithm? We are using this algorithm to insert an element in queue. Fine. So the name of the procedure should be meaningful. That's why here I'm going to give a name is queue insert. Fine. Now next step is, sir, what are the parameters we should pass over here? Okay. So students, here we have the queue itself. So queue, then two different pointers are there. In stack we have one pointer that is known as top, but in queue we have two different pointers. The first one is front, second one is rear. Front is used for the deletion purpose and rear is used for the insertion purpose. So we have Q, we have F, we have R. What next? After Q, F and R, we are going to insert something. That's why I'm going to take x over here. Instead of x, you can also take y. So here it is y. Y is nothing but it's a variable which is going to be inserted, or an element which is going to be inserted at rear end. Fine. So here the procedure q insert q f r y. One another thing we missed is that is n. N shows size of the queue. Remember, you cannot insert more elements in queue rather than its size. If the queue contains size 5, that means you can insert only 5 elements over there. Fine. Now let's show you the first step. Students, if you remember the stack, okay, the push operation of the stack, what is the first step over there? That at the time we need to compare our top pointer to n, that whether my top is greater than or equal to n or not. Correct? But here what happens? Here students, in queue we have rear pointer. Why? Because in stack we are going to do insert or deletion, any operation at the only one end, that is known as top of the stack. But here we are going to perform the insertion operation with the end rear and the deletion operation with the end front. So we have the separate pointers for each and every operation. So what I am going to do is I am going to first compare the position of the rear with the size of the queue. That becomes my first step. So here it is. If r is greater than or equal to n, then you just need to write the queue is overflow. Fine. If my rear pointer position is greater than or equal to n, the size of the queue, then the queue becomes overflow. So what to do? You just need to return at a home. That means you just get back to your next operation. You cannot perform the insertion, right? So here the return is a statement. Again, here the return is a statement. I'm not going to return any value from here. That's why the return is a statement only. Fine. Okay. So this is a procedure. I'm not going to return anything. The return statement shows that algorithm ends here. Now, the step number 2. If it does not like my queue is full, then what to do? Students, same as the stack push operation. Okay, I'm just comparing both of them so you will get a better idea that how you can perform the insertion operation in queue. So, if you remember what to do after the next in top, if my top is not really equal to n, then what to do? We are just incrementing top. Okay, so same process we need to do over here. Students, you just need to increment your rear pointer. Okay, so it becomes r is equal to r plus 1. So here it is, r is equal to r plus 1. So after incrementing the rear pointer, what will be our next step? We just need to insert our element over here. So if I'm taking my element, which is my element? My element is y. My element is y. I just need to take it and put inside into the queue of r. So that is my next step. Queue of r, arrow y. So such like the students, my insertion operation is completed. Now one step is left. That is set front pointer. Why? Why to set the front pointer is very much necessary. Let me give you the brief idea about it. See, just imagine a situation that your queue is empty. Your queue is empty. So students, when your queue is empty, your front and rear both pointers are pointing to the 0 position. Because here our array is initialization at 1. So whenever your queue is empty, your both front and rear both pointers pointing to the 0 position. Fine, clear. Now, if I'm going to insert something, my rear pointer will move towards the 1. My rear pointer is moved towards the 1 position. Fine, but f is still at 0. F is still at 0. Okay, now what happens? If I want to delete one, okay, then what happens? In the deletion operation, we need to move your front pointer. We need to move our front pointer, but right now my front pointer is at 0 only. Is there any element at the front pointer? Yes or no? No. Okay. So what happens? My front pointer does not contain any element. Then how it can return the deleted value? That's why. During the insertion of the first element, students, you need to check out that whether my front is at 0 or not. If is that so, then we just need to move my front pointer from 0 to 1. So now what happens after insertion of the first element? My front and rear both are pointing at the first position of the array. Fine. That's why what we are going to do is just set the front pointer. and the syntax for it, if f is equal to 0, then just write f arrow 1. Fine. Here our first algorithm is completed. That is simple queue insertion. What we did, we just did first compare the real value to n and then check out my first queue is overflow or not. How we can check it out? That if the real pointer position is greater than or equal to n, then my queue is overflow. If it's not overflow, then what to do? We just need to increment our real pointer, right? And after incrementing real pointer, assigning the value y to q of r, and then check whether my front is 0 or not, because we cannot leave front at 0 position. Fine, because it's the initial position when the queue is emptied. But now my queue has one value, so we should move our front pointer from 0 to 1. Fine. So this is your first algorithm about simple queue insertion. Now let's check out its example. So students, here if you can see my MQ is empty. That's why this is my queue. Okay. 5 size is there. That's why my array index starts from 1 to 5. And the front and rear both pointers are pointing at the 0 position. Fine. Now what to do next? See, if I want to insert 10, then what happens? The rear will take the place of the first position and f is also come back with the first and then insert it over there. Okay. If you check the algorithm, first the condition will check the whether rear is pointed to n or not. Is that so? No. So what to do? Just increment the rear. Now rear will be incremented from 0 to 1. It will be incremented from 0 to 1. Now assign the value. 10 will be inserted over there. Q of 1 is equal to 10. Q of 1 is equal to 10. Now the next, what happens? So suppose this is rear. Okay, this is rear, this is my 10. Now what happens next? This is my front pointer is at 0 also. So what happens? We need to check the condition for the front pointer. If f is equal to 0, then we need to move f to 1. Fine. So this is how you can insert the data. Okay. So let's move to the next step. If I want to insert 20, then what happens? Again, I need to check the condition. Right now my my front pointer and rear pointer both are at 1. So what to do? We just need to increment the rear. Rear will take the place of 2 and then 20 will be inserted over there. Same process will be done again and again. So this is my 30 after insertion 30. This is the figure after insertion of 40. And the last one after insertion of 50. Now, right now my rear pointer is at 50. So the value of the rear is 5. Value of the rear is 5. So if I am going to check that whether my rear is greater than or equal to n, the condition becomes true. So after that, if I can try to insert, okay, does the queue allow me to insert any element? No. So it shows the queue is full. Fine. So this is how you can perform the insertion operation in simple queue. Now let's talk about the deletion operation in queue. Students, the deletion operation is queue. That means here we are going to delete something. So as we have deleted or performed the pop operation in stack, same like the students here, what we need to check that whether my queue is underflow or not. Because if I'm going to delete something from the queue and there is no element in the queue, that situation is known as underflow. Okay. So just imagine if this is my queue. Right now my front and rear both pointers pointing at 0. That means my queue is empty. Because always remember that if your queue is empty, then your front and rear both pointers are pointing at 0 position. Fine. So what we are going to do over here? Here my array index starts from the 1. That's why if my front and rear both pointing to the 0 position, then it is known as emptied queue. So what to do? You just first need to write down whether it is function or procedure. So obviously it's a deletion operation. We are going to return a deleted element from this algorithm. That's why it's a function q delete. Okay, name must be meaningful. Do not forget this. Name must be meaningful. So function q delete. The parameters are f, q, and r. Here I did not need any type of n or y. So this is my first condition. If my f pointer is pointing at 0, ff is equal to 0, then obviously the queue is emptied and return 0. Write underflow and return 0. Students, why am I taking only f? If my queue is empty, then it must say f and r both pointing at 0, not only f. If my queue is empty, then f and r both at 0. But why should I take only f? Students, as we know that the f shows the front and front shows the deletion operation. So for the conveniency, I am going to take only f over here. If you write if r is equal to 0, then q is empty, you are correct. If you write f is equal to 0, the q is empty, you are also correct. You can write both of any one of them. But for our conveniency, for the better understanding purpose of the front and rear pointers, what we are going to consider is the front used for the deletion. That's why I'm taking front over here. Okay. Now, what happens? If f is equal to 0, then just write underflow. Now, the next step is if it's not like that, then what to do? See, if it's not like that, then first you need to delete an element. That means you just need to assign the q of f element to y. Here y is just a variable. I'm just taking a y variable to assign the value to take a value of q of y. Fine. So here I'm just assigning the q of f value to y. Okay, and then let me show something. See, if this is my q and if my only one element is there, just imagine a situation that only one element is there, student. Then what happens? Q, this is my q, then f and rear both pointer pointing at the same position. If there is only one element is there, then both f and r are pointing at the same position in the q. If this is 30 over there, f and r both pointing at the same position. Okay, now if I want to remove 30, delete 30, then what happens? 30 will go from here. 30 will go from here, then my q becomes empty. Then my q becomes empty. When f and r both at the same position. So during the deletion operation, if your front and rear both pointers pointing at the same position, then that means the queue is empty. So what to do? You just need to move your front and rear from any position to 0 only. So the first you need to check whether my front and rear at the same position or not. That step is known as if my f is equal to r, then move f and r to 0. Again, repeating this, if my f is equal to r, then move f and r to 0, because it only happens when the q is empty, and when the q is empty, my front and r both pointed to the 0. If it's not like that, then we just need to increment our front pointer. It's not like a top that you need to remove or decrement the top pointer. Here you just need to increment the front pointer to the next position. We'll understand this step better way in our example. Okay, so that's it. Last, you just need to return your y. Here we are returning something, that's why it's a function q delete. Okay, the previous one we are not going to return anything, that's why it's a procedure. Now, let me show you the example, how it works. So here students, the first the queue is, students 10, 20, 30, 40, the 4 elements are there. What I have inserted, I have inserted the 40 over here. So always remember in a queue, whatever you inserted last, at that time, QR pointer is pointing over there. Whatever you inserted first, on that position, the front pointer is pointing over there. So here my front pointer is at 10, then I have inserted 20, then 30, then 40. That's why my rear pointer is at 40. Fine. Now, what happens? If I want to delete something in a queue, okay, so the first operation is delete. See, you cannot write like delete 10, delete 20, delete 30, delete 40. Why? Because delete itself in a queue, it means you need to delete the first element which comes first. So it's the first in, first out manner. Okay, whatever the element comes first in a queue, it will be deleted first. So you cannot write like this, sir, I want to delete 10, sir, I want to delete 30. No, it's wrong. You just need to write delete operation. Fine. So here it is the delete. So when you performing the after performing the deletion operation, okay, first you need to check whether my queue is empty or not. Here my front is pointing at the 1. That's why f is not equal to 0. So queue is not empty. What should I need to do? I just need to assign my 10 to y. Second step. Second step of the algorithm. I just need to assign my 10 to y. So it will be assigned to y. Now what up to next? What up to next? My front pointer front pointer and rear pointer, both position will be checked. If f is equal to r, no, it's not like that. So what I need to do, I just to increment my front pointer from 1 to 2. So here it is, my front pointer from 1 to 2, and return y. That means my 10 element will gone. So here it is, it's gone. Okay, so my 10 element is deleted. So this is my new queue. This is my new queue. The new queue size is from 2 to 4, 20, 30 and 40. What up next? So it is when I again press on the deletion button, then what happens? It will check whether my front is 0 or not. If it's not like that, that's why check whether my front and rear both are pointing in the same position. It's again not like that, then just increment f and return y. 20 will be inserted into queue of, 20 will be assigned to y, return y, and 20 deleted from here. Fine, so here it is. Now let's check out the next step. This next step will be the same. The 30 will gone. Now the front and rear at the same position. Now check out the next step. If I want to press the deletion button again after removing the 30, then what happens? First check. F is equal to 0. No. So step number 2. Assign 40 to y. Assign 40 to y. So y is equal to q of f. So y is equal to 40. Fine. Step number 3. Check f and r at the same level. Yes, it is. Yes, it is, because after removing 40 students, after removing 40, what happens? F and R at same level. See, after removing 40, what happens? The queue becomes empty. Queue becomes empty. So when your queue becomes empty, your F and R both should point to 0 position. When your queue becomes empty, your F and R should point to 0 position. That is your step number 4. Fine. So what I need to just need to do this. Here my queue is empty. So F and R both pointing to the 0th position, and that's it. The algorithm of queue deletion. Fine. So students, we learned today about what do we mean by queue, what is the purpose of queue, right? Okay, do not forget to remember that front is used for the deletion and rear is used for the insertion purpose. Okay, when your queue is empty, F and R both pointing at the 0 position. Okay, when during the deletion, when your F and R pointing at the same position, then it must be at 0. Okay, during the insertion, when your rear pointer is pointing at the last size element of the queue, then it's known as overflow. So we learn about the overflow, underflow, queue empty condition. What do we mean by the queue and the types of the queue? Okay, so that's it. If you have any doubt in this subject, particularly in this topic, then let me know. Thank you so much.